Hi students, we're just going to do a few more problems on the standard addition algorithm, and we're going to do those problems in different bases. So I'm going to begin by doing them without the base pieces, but then show you that it's perfectly fine for you to use the base pieces if you want. Okay, so let's start with, let's do 4, 5, 7. And let's go with base 8. And we'll add to that about 3, 6, 5. And again, well, that would be pretty scary if we had to add one number in one base to another number. I don't think that would work very well. All right. So when I add these, we need to modify our standard algorithm. So I'm not trying to get 10, I'm trying to get 8 because I'm in base 8. So I've got 7 and 5 is a total of 12 ones, or 12 babies. So I need to take 8 of those 12, right, and move that over to the next column, which is where I keep track of longs, which are 8s because I'm in base 8. So again, I had 12 babies. I take 8 of them and make a long out of it, so I move it over. And that means I have 4 babies still remaining in this column. So now I repeat. So I'm with longs. So that's 12 again. And I'm going to do the exact same thing. Of those 12, I'm going to take 8 of them and make a flat. I'm going to have 4 left to leave here. Now I look to see what I've got. I have exactly 8 flats, and I'm going to take those 8 and I'm going to make a block out of them. So I'm not going to have any left, but I'll have 1 block. So my sum is 1044 in base 8. So if you wanted to do the base pieces, which again is fine, I'm going to represent the first number with 4 flats, 5 longs, and 7 babies. And then I've got 3 flats. I've got 6 longs and 4 babies. So I combine these together and I have 1, 2, 3, 4, 5, 6, 7. Something went wrong here. I need 5 babies there. All right, so I need to take 1, 2, 3, 4, 5, 6, 7, 8 of my babies. I am in base 8, so my conversion rate is 8. And make a long out of that. So there's my 4 babies that are left. And now I have 1, 2, 3, 4, 5, 6, 7, 8. Again, I have 4 left. These get turned into a flat. I take all 8 of these. I turn those into a block. So I have 1, 0, 4, 4, which matches exactly to what I had before. All right, let's do one more problem. Let's go base 12. So let's do 4t e and 12. And we'll add that to 8, 3, 5, and base 12. All right, so in base 12, we have to remember that t means we have 10, and e means we have 11. And our exchange rate, of course, in base 12 is 12 objects. So we have 11 ones plus 5 ones. So that is a total of 16 ones. And with the 16 ones, I need to take 12 of them and turn that into a long. And there were 16. I just used 12 to make a long, so that means there are going to be 4 left. So I move over to my 12s, or my longs. I've got 10, 13, 14. So again, I am going to take 12 of those 14 and make a flat. And that will leave me with 2 left. And now I've got 12, 13 flats. So I'm going to take 12 of those and make a block. And since I had 13 and I used 12 of them, I have 1 left. And I have that 1. So my answer is 1, 1, 2, 4, base 12. So again, I can back this up with the base pieces if you are having trouble doing it without. Of course, we get into this higher base, and it's a little tedious to draw the pictures, but worth it. All right, so I've represented my 2 addends, and now I'm going to combine them together. So I have 11, and then I need this 1 more down here to get me a group of 12. So there's my group of 12. I make a long out of that, which are my 12s when I'm in base 12. And so 10, 11, that'll be my 12th. So I take 12 12s and I get a 144, which is my flat. And I have 2 left. So here's my 4, here's my 2. And now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I need to take all but one of these to form the next size group. I get a block or a shadow, however we want to call that. So I have 1 left, and I've got 1 of those. So I get the exact same answer. All right, I hope you guys are feeling good about the standard addition algorithm.